Okay, for today in Honors Pre-Calc, I get to explain that I think, at least in one of my hours, that I said this improperly yesterday, and I want to make this clear. The assumption I want you to use to do this abbreviated CAN lab, in my classes, I am not having you do the entire CAN lab. We're trying to save some time on this. I am telling you to use the assumption that if this is the height and this is the radius of your CAN, the ideal CAN, after you did a bunch of checking with, here's how much surface area this CAN has, and here's how much square inches or square centimeters of metal it required, you would come to the conclusion that the ratio of the H to the R is 2 to 1. Okay, that was what I was trying to tell you yesterday, is that ratio. The ratio of the H to the R is 2 to 1. Now, what does that really mean about the height of the CAN and the width of the CAN? They would be the same. So diameter of the CAN to the height of the CAN would be 1 to 1. That's the ideal CAN. So again, if you're going to compare radius to height, it is 2 to 1. But I think I was saying that incorrectly yesterday. It was using the height. I don't even want to try to repeat what I said yesterday in case I just mess you up worse. So this is what it should be. All right. So if I was going to label this CAN, tell me, do you get that I really want to get this down to just one variable? And therefore, if I can get it down to one variable and know that the height isn't the height, it's, let's say it's x, then I would want to make the radius also in terms of that variable. Okay, so what do you guys think would be smarter? Do you think it'd be smarter to make the height x or the radius x? It doesn't matter. You can do it either way. You want to make the radius x? Okay. If the radius is going to be x, why are you thinking that's a better way to do it? Yes? And the height will be 2x. So my first step in making a word problem work is I make the picture of it, and then I label it as best I can. And if I can label it with only one variable, that's definitely the best. And it takes some work to do that, but then that makes everything else go so much easier. My process for word problems next involves the pure form of the formula involved. Do you remember what the CAN lab is trying to accomplish? It's minimizing surface area, but they give you a specific what? Volume. Okay, so what is the volume formula? For a pure form of the formula, and that includes the beginning and the end, because sometimes people think they don't include the volume equals, they just go length times width times height or whatever. You need the whole thing. Now, who's got this one memorized? Yes? Pi r squared h. Good. Now, that's the pure form of the formula. But do you get, with the picture that I have, r isn't r anymore, and h isn't h anymore, and v isn't v anymore. What do you mean v isn't v? Because they told us the volume. What did they tell us about the volume? The volume's 1,000. All right. So from here, once you have your equation, I don't want to do too much of this. I'm already doing a lot to try to get you through this lab super quickly. Once you have your equation, let's say that this was your equation. This is not your equation, but let's say it was. Then, how do you solve an equation like this that's really complicated looking? I personally would use graphing. And how do you solve problems with graphing? You could set it equal to 0, but there's a faster way. All right. Then one of my themes in this class that you need to get, and I'm amazed at how long it takes for this to kick in for kids. You can solve any equation by just graph both sides and see where they cross. And yet a room full of really smart kids, and nobody could come up with it. That's amazing. So because I know I've said it to you at least 4 times so far this year, and there'll be another 5 times, and some people still won't remember at the end of the year. Graph both sides and see where they cross. Let me give you an example. Let's say I had 2x and x plus 4. Did you know that you could solve by graphing both sides and see where they cross? You probably didn't. You probably weren't ever told that before. You were always shown, okay, subtract x from both sides, and yeah, that is a faster way to do it. Let's actually look and see what we get. X equals 4. Oh, interesting. Does it actually work? Well, if we put a 4 here and we put a 4 here, does it actually work? Yeah, okay. Now that way of doing it is great, but what you weren't shown was that you could have graphed both sides and see where they cross. Y equals 2x and y equals x plus 4. I'd like you to grab your graphing calculator right now, and I'd like you to graph those two and see where they cross and see that that actually works. Graphing both sides of an equation and seeing where they cross is a really good way to solve ACT questions. It's kind of slow, but it'll definitely work. If you want to borrow one of my calculators, I'll pause for a second while you do that. All right. Without a calculator, I made the numbers easy enough that I could even do this without a calculator. When I graph y equals 2x, I know what that looks like. That's a slope of 2. It's a pretty steep line, right? And then the other one is y equals x plus 4. That starts at 4, and it has a slope of 1. So it goes like this. And because I already know the answer, I'm cheating. I know the answer is 4. Do you get that I know that that spot right there, that must be where x is 4. 4 comma, I don't know, but you've got your calculator already graphed, okay? You graphed y equals this and y equals that, and you can see where they cross, right? Second calculate intersect tells you exactly where they cross, if you want to do it that way. And what was the spot where they crossed? All right, some of you aren't even doing it. That's frustrating. I'm going to pause for a second while I get this fixed. All right, after you've graphed y equals 2x and y equals x plus 4, you will find this spot, the spot where they cross, and it's something comma something. How many of the groups have that point identified? Raise your hand if you do. Okay, that's almost everybody. All right, would you tell me what point you guys got? 4 comma what? 4 comma 8. Now, this is important. Do you get there's two numbers to choose from? If you're finding the answer, you better not say the wrong one. It's either 4 or it's 8. We already solved it, so if you've got any short-term memory at all, you know the answer is 4. But why? Well, the x is 4 and the y is 8. What were we trying to solve for here? X, and therefore the answer is 4. Okay, now what's cool about this method of graph both sides and see where they cross is it can solve even things like this. You have no idea how to solve that with any other method, but what did I just tell you? You can graph both sides and see where they cross. Do you get sine is a wave? Do you get 2x plus 4 is a line that goes like this? Do you think it's likely they might cross somewhere? Wherever they cross, that's the answer. Okay, so this can solve even weird things you can't solve any other way. Graph both sides, see where they cross. All right, so I needed to make sure you understood that concept, because why? Because on your lab, you're going to have this equation, and you're going to have the 1,000 for your volume, and you're going to have something over here for your equation, which you need to figure out, and then you're going to graph both sides and see where they cross. And y equals 1,000 is like way up here, and the other one's going to be some curve, and let's say it, I'm not sure exactly what it looks like, but let's say it looks like that. What's the important spot? Where they cross. And then you'll have to interpret it. If this is like how many ponies you have, then you'll be able to say, I have 12 ponies. Okay, but that's not what the question's about. I'm not telling you anymore. You got to figure out what x is. You got to figure out what y is in the context of your question. Kind of depends on how you labeled your picture. And then you should know what x is from your picture. Okay, so it's all about going between the graph and the equation and the picture of what's really happening to try to solve it. All right, so now your lab is due next Wednesday. Okay, so you can work on it this weekend, check with a friend, see if they're getting the same thing as you. Make sure you do things like, don't forget the sketch. I mean, there's a format for all the labs. We're going to grade the sketch. If the sketch isn't there or the sketch isn't labeled, you're going to lose points. Don't forget the purpose. Don't forget the conclusion, you know, and things you learned about math. And you can't just say, like, I learned how to graph a polynomial. You have to, like, come up with better stuff than just, I learned to graph. All right. That's all I got for you on the lab. Now, let's move on to the new stuff for today, which is about logs. Everybody please find the file that looks like this. We were going to start it yesterday. I realized you guys had a lot of questions about your test, and I spent most of the time talking about that. So today it's just logs. Now, I know some of you guys have issues with Wi-Fi and might not be able to find this thing. If not, just use a blank Notability doc and it'll be fine. I'm going to pause for a second while I get to the right spot. Okay, so the secret to logs. The secret is it's all about how logs are related to exponents. All right? So these log properties are going to mean absolutely nothing to you right now. We will teach you those on Monday. But this looks super complicated. If anything, it can just make it look like, whoa, we're going to learn this really, really hard stuff. But it's really easy as soon as you get to understand the basics, okay? So let's make sure you understand the basics, this whole secret to logs. Okay, that is a typical log question, log base 3 of 81. And what in the world does it mean? Here's my intro to logs. If you said 5 to the x equals 25, all of you, given a few seconds, could figure out, oh, x must be what? X must be 2. 5 squared would be 25, right? Okay, but 5 to the what equals 24? That's a more intriguing question. And how do you solve it? You don't have a way to solve it. Now prove me wrong. You do have a way to solve it. What did I just tell you a second ago? Some of you have already forgotten. It's amazing how that just flies out of your head. Graph both sides, see where they cross. Do it. Isn't that amazing? I'm amazed by it. I take 5 minutes like saying how important graphing both sides, see where the cross is, and then as soon as we hit a new kind of problem, you're like, I don't know, how could I solve that? Graph both sides, see where they cross. Now, I want you to just think about it for a second. 5 squared is 25, so it's got to be kind of close to 2, doesn't it? All right. 5 to the x is an exponential, and so it kind of looks like this. 24, y equals 24 is a straight line that goes across like this, and wherever they cross, it must be my answer. And it's like 1.94 or something, comma 24. What is that number exactly? 1.975. Thank you. So, moral of the story, it is weird how people forget they can graph both sides and see where they cross. Okay, but there's another way. In the old days, I used to just say, there is no way to solve this unless you use logs. And then I realized I myself was forgetting that you can graph both sides and see where they cross. Okay, but logs is the main way that you would solve this problem. Now, we already know the answer is 1.975, okay? But how could you solve it with logs? What are logs meant for? Now, do you get that a long time ago there weren't graphing calculators? It wasn't even that long ago. When I, 30-some years ago, was in high school, we had calculators, but there was no graphing. Okay, that was not an option. You had like simple multiplication kind of stuff. They could add, subtract, multiply, divide. But when you go way back, there were not even calculators that were electronic, right? They had things that they could use called a slide rule that was like this stick, and it's kind of amazing how a stick with numbers written on it could actually multiply things and stuff. But this is meant for when there wasn't graphing. I wonder if logs would have even been invented in the age of calculators. I think it would have, because it does a lot of other really cool things. But one of the things that it can do is to rewrite this exponential. By the way, why is this an exponential? Because it has an x in the exponent. That's what makes that exponential. It can rewrite it as a log, and it's log base. Now, of these, what looks like the base? 5x or 24? What feels like a base to you? The 5. Most people's gut on that is right. That is the base. The 5 is the base, so it's log base 5. That's how you say this. Log base 5. And now, it would be so nice if it was just intuitive, and the next thing I would write is x, but it is not that way. So there's only 3 things. There's a 5, there's an x, and there's a 24. So I just told you it's not as simple as just the next thing's the x. It's not. It's the 24. Equals x. There, I have rewritten an exponential into a log. And now there's some terminology that you need to know. That's called the base. This is called the argument. You could argue about why that is. And that is called the exponent. Take a look at the original problem and see why you think it's called the exponent. All right, because it's in the exponent spot there, right? Base, argument, and exponent. That's the 3 major components of logs. All right, let me tell you a reason why you care about logs. One is it's used to make the Richter scale. Have you heard of that one before? Another one, it's used to make the decibels scale. Okay, you've heard of decibels before, probably how loud something is. Okay, another one, logs are really good at writing equations for real-world situations. And lastly, one of my kids came back, one of my better students from last year, and logs was her weakness. And she's like, you know what we're doing right now in calculus? Tons of logs, and I suck at logs, and now I got to do derivatives of logs, and oh my gosh. So anyway, this is in calculus. No matter whether you take HL version or either you take the AP version, logs come up in calc, in AP Calc. Okay, so you got to get this stuff down because it's going to be used in calculus next year. And there's other reasons because, again, it can be very useful to engineers and people who, you know, are heavy math science people in the real world. Okay, so this, you might think, okay, so what's any better about that than this? Because you can just type that in a calculator and get the answer. Okay, let me show you how. It's not as simple as you would think. TI has improved their calculators so that some of you have a way to just type that in directly. Log base 5 of 24 equals, and then you'll get that 1.975 answer we got before. But a lot of you don't have that operating system. Okay? If you have one of the, if yours isn't brand new, it may not have that. If yours isn't one of the new ones, then to put this in a calculator, you will go log 24 over log divided by log 5. You know where I got that? Here's the log 24, here's the log 5. If you do log 24 divided by log 5, you will get, if you do it right, 1.975. Would you try that right now? Maybe, and some of you are going to find out, ooh, cool, I've got the cool operating system, then I don't have to do that. I can just type in log base 5 of 24. Log 24 divided by log 5. And what does that mean? If you go back to the original, you're finding the exponent. See, this is the exponent. The exponent from the original problem must have been 1.975. All right. I'll give you another one. 2 to some power is equal to 19. Would you please, this is the secret to logs, is being able to change exponentials into logs and change logs into exponentials. Have you learned how to make this into a log yet? Log base what of what is equal to what? Did you have base 2? Did you remember that it's not in order, so the next thing is not the x. The next thing is the 19 equals x. And now, Kids say this in an amazing array of ways because they haven't learned how to say it properly. All right, I'm going to pause for a second. Okay, let's see if anybody wrote it out exactly right. You should have said log base 2 of 19 is x. Equals is also okay. How many of you had it exactly right? All right, 8 people. Okay, I think you get the idea. This is not natural for you. What are the, write down this part. That's base, and then I would say of, log base 2 of 19 is or equals x. So you really only need 2 little helper words in there, base and of. All right. You can almost think of logs as a different language. It's a different way to do math. It's totally different. You've never seen it before. All right. Now, if I gave you a log, could you go the other way? Log base 3 of x is equal to 4. That's a log problem. Can you rewrite it as an exponent problem? Did you have 3 as your starting number? Did you then realize that these don't go in order? So therefore it can't be x next. I know a lot of people put it to the x. I don't want to even ask who did, but I know a lot of people did. 3 to the 4th equals x is what you should have put. Notice it doesn't go in order. That jumps over to there, jumps back over there. Okay? And then what's the actual answer? It's 3 to the 4th, which is 3 times 3 times 3 times 3, which you can actually do in your head if you think about it. Break it up into a couple of 9s. What is it? 81. You don't have to do it in order. You go 9 and 9 and 9 times 9, 81. Okay. So if it's 81, that means that there could be an 81 right there. And that means that log 81 divided by log 3 would be 4. Or if you have a way of putting it in directly in your calculator where you go log base 3 of 81, cool, it should be 4. Would you please verify that with your calculator right now? Just make sure you can make this go in the calculator. That's what I'm trying to say. What I would do is log 81 divided by log 3, unless I had the fancy software, which makes it easier. Out of curiosity, how many of you got the fancy software that you can just put it in directly? All right, so there's like 6 people who have that little advantage. Good point. You'd have to know exactly where it is to find it, but again, not a lot of you don't have it. Even if you knew what buttons to push, if you don't have the newest version of the operating system, then you have to go divide like this. Now, honestly, it's not that bad to have to know this because that's one of the topics. It's called a base change. That's called a base change because, look it, the base was 3, but these don't have bases. What? Then that means they have bases. They just have a base that's so common that you don't even have to say it. What base do you think they are? Nope, not 1. Yes? 10. Base 10. We're in a base 10. Do you get out? I could put a little base 10 there. So you changed a base 3 into a base 10 when you did that division. That's called a base change. You will understand that more later. But if I just write log 6, it's important to understand what the heck does that mean for a base. If I don't say the base, it means the common base. It's called common log. And that means there's a base 10 that you don't even see. All right, you'll learn a lot more about logs here as we go on. But if you walk out of here with only one thing, you got to be able to take this and rewrite it as an exponent problem. Would you please be able to show me that you can write that as an exponent, and then I'm going to make one the other way around. Write that one as a log. You got to be able to go back and forth. These are completely different. Don't try to get them conflated. This needs to be rewritten, and this needs to be rewritten. This needs to be an exponent problem. This needs to become a log. I'll move it up a little higher. A lot of people are craning to see it. I'll pause for a second. Okay. Dice of Destiny. Who should I call on to answer that top one? It's row 6. Last person. There you are. 3 to the x equals 2. That is correct. You have changed a log into an exponential. Raise your hand if you got the same thing. Okay, good. This other one. Log, and then think of it, if you know how to say it, you should be saying log base. That reminds you, oh, it's a base that I need, and that's a base, and then it's log base 8. And then if you just remember, it doesn't go in order. It's not x next, it's 52 next, equals x. There you go. There's a lot more to learn, but if you don't have that part down, then you didn't really learn anything today. That's the most important thing, okay? All right. Now, let's go to a few of these properties of logs that I think I can handle today that'll help you answer these kind of questions right here. All right. So I'd actually like to start these problems with you, and then I'll teach you stuff as I need to help you get through them. All right. So this is your first page of your homework. And what they're asking you to do is rewrite the exponential equations as logs and rewrite the logs as exponents. That's exactly what I was just asking you to practice. It's just some of these look more complicated. So here's one. Can you make a log for it? Log base what? Base 5 of what? 1 over 125 is equal to -3. Now, if you were to actually use a calculator, you could verify, and I'm not asking you to do that, but you could, that log base 5 of 1 over 125 is -3. Now, later you'll understand why it's -3. But right now, all I need you to be able to do is rewrite that. Okay, let's move on to this one. That one is already exponential. So I should rewrite it as a log. So log, what's the base? 4 of what? 32 is 5/2. Let's pick a different one that looks weirder. Let's look at number 9. It's a log right now, so let's make it the other thing. So if I just say it, I'll say log base 25. Oh, I need the base to be 25. To the power of 1/2 equals 5. And does anybody actually understand what does that power of half mean again? So if you can do this one in your head, you can go 25 square root is 5. Oh, it actually works. All right. So all we're doing on this page is rewriting. Let's move to the next page. Evaluate the expression. That means you actually have to get the answer. All right. So then I need to teach you a property about logs, and I'll do it by, there's a bajillion problems here, right? And it says 4 minutes total. Yeah. I don't think so. But I'll do some with you. All right. So look at that top one. First of all, it doesn't have anything that it equals. So I say equals x. You get what I'm saying? It doesn't have an exponent spot there. So I need to say, I don't know what it is, so I put x. And now I can rewrite it, right? 3 to the x equals 27. Can you do that in your head? Because I can. See what I mean? I now know what x is. What's x? 3 to the second would be 9. Try again. 3 to the third. So x must be 3. I've evaluated the expression. So I started by saying it equals x. You're going to want to do that on every single problem. You don't have to write an x on every single problem, but you'll get the hang of it. If I say equals x, then I rewrite this thing. This is 6 to the x equals 1 over 36. Now that might fry some brain cells, but 6 to what power would normally, how about if it was just 36? It'd be 2, but the answer can't be 2 because, somebody caught it. What is it? Negative 2. 6 to the negative 2. You got to remember fraction exponents for this thing. And exponents that are negative. 6 to the negative 2 would be 136. So I solved it. X equals negative 2. All right. This one, I better finish it. X equaled 3. This one, I start by saying equals x. Next thing I do, rewrite it. 1/5 to the x is equal to 625. That's evil. The first thing you want to think is, how do I make a 5 into a 625? It's not a nice number. 5 to the 4th power is way, I think that is 5 to the 4th power. Good. So then is it as simple as to the 4th power? Is x just equal to 4? Would 1/5 to the 4th be 625? No, it's not going to be exactly. So something's got to be different about the 4, yes? There you go. Why? Because a negative power takes your answer and flips it over. 1/5 to the 4th would have been 1 over 625. We need it to flip over and be regular 625. So it's x to the negative 4th. All right. Wait a minute. This one doesn't even have a base. Yes, it does. What is the base? It's a 10. And it doesn't have an answer, so I say equals x. Remember, if there is no base, then that means it's base 10. Okay. Now I can rewrite this thing. 10 to the x equals 1 over, is that a million? Yep. I know x isn't just a big number. It has to be a negative big number. Because x to a big number would be a big number. And this is 1 over a big number. Anytime you see a 1 over or a fraction, you can figure it's probably a negative involved. Negative, and then 10 to the what? 10 to the first would be 10. And I could just keep doing it that way. First, second, third, fourth, fifth. What do you guys think this is? I think it's 6th? All right. And if you weren't sure, you could go 10 to the negative 6 and then work it out. What does that really mean? It's like 1 times 10 to the negative 6. Does that sort of look like scientific notation to you? So you could figure out if you're actually going to get the answer you want. 1 times 10 to the negative 6 is a 1, where you move the decimal 6 spots to the left. And if that's the same thing as what we wanted, 1/1,000,000th, then we did it right. All right. When you look back at this, you're going to long for these problems because these are going to be the easy ones. Like right now, I know this might feel a little tricky, but this is not, these are not that hard. They're just rewriting them into exponent problems and knowing about negative exponents and square roots. All right, so this one equals x. And then I go 4 to the x equals 8. And then I just think about it and go 4 to the x equals 8. That's not going to work out real nice. 4 to the second isn't 8. And this is the first one where you would have to use a system called a base change. You did this in higher algebra, but I don't know if you remember it or not. Would you agree that 4 and 8 could both be written with a base of 2? 4 is 2 to the second, and 8 is 2 to the third. So this is 2 to the second to the x equals, what's 8? 2 to the third. And if the bases are the same, you can cancel them. And the answer is 2x equals 3. From there, I know everybody in here knows how to solve 2x equals 3, divide by 2, and I get 3 halves. The answer for this was a fraction exponent? Yup. All right, I'm going to show you another one like that. Do you get that 6 to the x equals 36 is one you could probably do in your head? Okay, but do you get that these both could be written with a base of 6? I'll show you that base change thing again. This has a base of 6. 36 could be written as 6 squared. Do you get then x equals 2? If you can write the bases the same, then their exponents must be the same. Here's another one. This is similar to the one we just did a second ago. Couldn't they both have a base of 2? That's 2 to the what? And it gets really quiet. I know I'm losing people, but it's not that hard. What's 2 to the what is 8? 2 to the third to the x equals 2 to the second. Bases cancel. 3x equals 2. X must be 2/3. X to the 2/3 power is 4. Okay. Let's see if you're really understanding this fraction exponent thing. What is 27 to the 2/3 power? What? That's the root part. That's the power part. (27) to the 1/3 to the 2. That's the same exact thing as 27 to the 2/3. Can you do this part, the third root of 27? What's that? 3. And then you take that and you square it, which makes 9. Answer is 9. What's 125 to the 2/3 power? Start with the root, then square it. (25 to the 1/3 power? 5. 5 squared? Answer is 25. All right. You're going to need that as we proceed on the homework. Now, your homework, I'm going to just sum up here. All these was rewriting them and solving them. This is the second page. And there will be some times when you have to do fraction exponents to be able to solve them. Like that's what we just did here. And I showed you how to make the bases the same to solve them. Okay. We don't have to do all of these. I'm going to cut off from 30 on. Everybody cross off from 30 on. The first page of this was easier, right here. You can do that whole page. Those are just rewrites. And that's it. Finish this page. Oh, one last thing. ln. That's log base, do you remember? Log base E. Awesome. Anytime you see ln, I encourage you to write log base E. In case you've forgotten, E is about 2.718. It's a number that's kind of like pi. It's defined as always this. E isn't a variable. E is a number. And it's a special number that's used in logs. We use it a fair amount. And if you've ever seen the ln key on your calculator, sort of looks like log, that means log base E. So whenever you see a log that doesn't have a base, the problem's going to become all about the base. And the ln's, they have a base that's missing too. There's no base, but I know that's log base E. Make sure whenever you hit an ln, you change it to log base E. And I'm telling you, usually the problem ends up being all about the base. If the base is not there, it's kind of like, can the kid figure out what the base is? Because that'll be crucial to solving the problem. All right, so this whole page, but skip 30 to 42 there. Just scribble out that end part. And that's it. Of course, there's more to learn on logs, but that's enough for today. I know it was kind of intense, but logs are critical. They are something you're really going to want to know when you hit calculus. They do occur in the real world. Logs don't occur, but we can use logs to describe math equations for real life situations. This is good stuff. And if I remember correctly, in higher algebra, you were introduced to logs, weren't you? This isn't completely new to you, is it? Okay. But we are obviously going extremely fast. Like when you learned it last year, you probably had a week worth of it, and you would have ended with today. Yeah, units are usually, okay, week, maybe 2 weeks. And this would have been like day 4 or 5 or whatever. So I know this is kind of intense, but hey, it's supposed to be a review / actually, I think you probably didn't even do some of these. I think this is a review / a little bit of new stuff, especially with those fraction exponents being so prevalent. I get this is not super easy. All right, but you need to get this down before we move on. So do a good job on this weekend. Okay? This is not the one to get a little lost, because then, oh my gosh, you're going to be really lost on Monday and then really lost the day after that. Yes? Sorry, just scribble out the ones I scribbled out. I probably said it wrong, but you see which ones I scribbled out there? Just scribble those out. Do the rest of them on the page. And obviously, I've already done quite a few of them for you. So, all right, that's all I got for you for today.